Hi, I'm Brian. Today we're going to be going over an SAT math question involving equivalent expressions that also ties in some quadratics and some tricky work with some fractions here. So we're given this expression to begin with, and we're asked to figure out an equivalent form of this expression. So anytime you're dealing with a fraction within a fraction, what you want to try to do is get rid of the denominator within the denominator. In other words, we want this x minus 2 to go away. We want this x plus 5 to go away. So let's focus on that first. In order to make them go away, we have to multiply by a common multiple of them. In that case, we're going to multiply by x plus 2 and x plus 5. We're going to do that to both terms, so I'll write it on both sides just so you can see it. And then since we did that to the bottom, we have to do that to the top of this fraction. And that looks like there's a lot going on, but all we're really doing is multiplying the bottom by one thing and multiplying the top by the same thing. So when I take this first term of the denominator and multiply it by this, the x plus 2's cancel. And that's actually what we were looking for here. So we're left over with just 2 times x plus 5. And then when we multiply this term by the same thing, the x plus 5's go away. So we're just left with x plus 2. On the top, if we FOIL these, if you use that terminology, or just distribute everything, we end up with 3 times x squared plus 7x plus 10. And if you note and look at your answer choices here, at this point you can see that x squared plus 7x plus 10 in the numerator. If you had to guess at this point, that'd be a pretty good guess. I'm going to keep simplifying this so you can see where it comes from. Down the bottom, if you distribute in the denominator, that it becomes 2x plus 10 plus x plus 2, and if you keep going, that becomes 3x plus 12. On the top, we still have this expression up here. Note in the bottom, you can take out a common factor of 3, and you're left with that x plus 4. On the top, we've got this expression. Those 3's go away, and that's where this final answer comes from.